Hello, guys. So, welcome back to one of our last days of the week, Chapter 1, Day 6. All about, it's kind of a mix of two things. It's a little bit of a recap, which we actually did it in our quizzes today. We worked on this. This is where our quizzes came from, these 6 problems. So, if you missed that, guess what? Now you have a chance to look and work and make sure that you feel good on what we reviewed today on quizzes. Now, something new we're going to be introducing today are multi-step. And all a multi-step equation is, it is an equation with more than 2 steps. That's all it means to be a multi-step equation. It just has more than 2 steps. So for example, 1 and 2 here are one-step equations. You subtract 15, you got your answer. You multiply by 5, you got your answer. These are 2 steps. Subtract and divide, multiply and subtract, multiply and subtract. Now, before we get into multi-step equations, it's going to be important to know some properties that are going to help us with multi-step whenever you have a bunch of steps going on. The first one is the commutative property. So I'm going to use some letters here for commutative property. I'm going to use, let's go with A and B. I'm not going to go X and Y, that's boring. So commutative property says that if you do A plus B, that is the same thing as doing, what do you think? That's right, B plus A. When you add, it doesn't matter which way you add. Think about it this way. 2 plus 1 is the same thing as 1 plus 2. The associative property. Now this property comes into play whenever we have multi-steps that involve some parentheses here if you want to think about it. It actually involves the order. So if you have A plus B, and you're doing that first, and then adding C, as long as you're adding, that is the same thing as doing B plus C, so you do that first, and then add A. So the associative property says that if you have 3 things all being added, it doesn't matter the order. Order doesn't matter with addition. This also is true for multiplication. So addition and multiplication, guys, look over here. 2 times 1, guess what? It's the same thing as 1 times 2. So not only does this work with addition, it also works with multiplication. And speaking of multiplication, a multiplicative inverse. So we know we're dealing with multiplying. Now, a multiplicative inverse, this just says that any number can be multiplied by its inverse and destroyed. So in other words, let's say we have 2. Now, 2 is a number that could also be any number if we wanted it to be 3, 4, 5. But it is a number that if you multiply it by something, a specific number, it will return to 1. It will return to the baseline number. And the way that happens is by multiplying by its inverse. Well, what's the inverse of 2? Well, 2 is really 2 over 1. You can make any number a fraction if you want to. 2 is 2 over 1. That's 2 divided by 1, it's just 2. But the reason I do this is because its inverse is going to be this, flipped. So 2 over 1, if we multiply that by 1 over 2, guess what happens? 2 times 1 is 2, over 1 times 2 is 2, and guess what 2 divided by 2 is? 1. You can take any number, multiply it by its inverse, and get it back to 1. How about multiplicative identity? So every number has an identity. Let's go with 5 this time, representing Kevin Garnett, my favorite athlete. Identity means what can we multiply this by that will keep it 5. So if you have 5 and we want to multiply it, what number can we multiply 5 by to keep it 5? That's right. You could use 1. 5 times 1 is 5. 7 times 1 is 7. So on and so on. How about, real quick, additive inverse? So we had the multiplicative inverse. We said that's multiplying by the reciprocal. Additive inverse is us adding a number. Let's go with 6. What could we add to 6 that would be the opposite of 6, that would cancel 6 out? The inverse. Some of you guys got it. -6. 6 plus -6, 0. You can think of it this way: a plus -a, 0. And you're going to notice that 1 was involved a lot with the multiplicative problems. Multiplicative inverse ended up giving us 1. Multiplicative identity involved multiplying by 1. The additive inverse, when we added these together, we got 0. Guess what additive identity is going to mean? Let's say you have 21. What could you add to 21 that would keep the number the same? What could we add to 21 that would keep it 21? You got it. 21 plus 0 is 21. So a number plus 0 will always leave us with that number. And finally, let's look at a property I know you've seen before, the distributive property. This property has to do with multiplication, and it says that if you have a number on the outside of some parentheses, so we have a on the outside of parentheses b plus c, that you can multiply a into both pieces, a times b and a times c. So that would give us ab plus, don't forget about that plus still being there, plus ac. And so those are 6 kind of simple but incredibly important properties, guys. And what I'm going to let you do now is I'm going to let you guys see if you can label which of these 4 is which property. So you can go ahead and pause the video and see if you can label these properties. Okay, so number 1, we see that we distributed that 5 to A and that 5 to B to get 5A plus 5B. So we're talking distributive property. Number 2, -10 plus 4 is the same thing as 4 plus -10. Oh, they switched around the terms, but it's still going to be the same thing. That is the commutative property. 4 plus 0 is 4. So we're saying if you add 0 to that number, it keeps its identity. Its identity doesn't change, and we're adding. So that is additive identity. And then finally, if you take 1/2 and you multiply it by 2, which we know is really 2 over 1, you're taking a fraction and multiplying it by its reciprocal in order to cancel it out and take us back to 1. That's multiplicative inverse. When you take a number, multiply it by its reciprocal, its inverse, in order to get it back to 1. Now, let's really get into how we do multi-step equations. So these follow kind of a very, very similar pattern. Step 1. Work with parentheses. So look for any parentheses, see if you've got them, and if so, those have priority. We either need to take care of what's inside of them, or we need to distribute a number into them if there's a number being multiplied to them. Step 2, combine like terms. And the key here is, I can't stress this enough, start with variables. If you have multiple variables of the same kind, get those all over on one side. Combine those first. Step 3, combine like terms. Then you can do these with regular numbers. So after that, you're really going to be left with a variable on the left or the right, and then a number on the other side. So you'll have, once you've done this, you'll have gotten down to maybe something that looks like 3r equals 9 at this point. So then step 4 is almost always either divide, which is usually what you'll do, or multiply to solve. 9 times out of 10 you'll divide, but sometimes you'll be multiplying. If the last thing is a variable being divided by a number, then you have to do the opposite, which would be multiply. So let's put these 4 steps into practice. Now, step 1 you won't always do. Working with parentheses. Well, look at number 1. We're going to be solving these. No parentheses. We don't even have to worry about step 1. Step 2, combine like terms, and we're going to start with the variables. Oh, now we're in luck here. We have 2 variables that are actually on the same side of the equation. So we can just smash those together. Both of these are on the left side of this equal sign. So we have 7 minus -1 and -1. That gives us -2y equals -1. So we've done step 2. We've combined all our variables together into one space. Step 3, combine like terms that are regular numbers. So we have a 7 and a -1, but there's an equal sign here. They're on opposite sides. So we don't want to bring this over. Don't do that. We want to get y by itself to solve, which means we need to move that 7 over. So if it is a positive 7, we will subtract 7. -2y equals -1 and -7 gives us -8. Then we divide by -2, and a negative divided by a negative gives you a positive. Nice work, guys. Let's do one more together before I let you guys try one. Let's look at number 3. So this time we got 13 over here. Okay, we only have one variable. That's good. But we have 2 numbers shown here. So let's go up here. Step 1, work with parentheses. No parentheses. Step 2, combine like terms. Start with the variables. There's only one variable. We're good. Step 3, combine like terms, regular numbers. Here's where it gets interesting. We have 3 different regular numbers here. Let's start by combining the ones that are on the same side. So 5 and -13. We can combine those together even though 3b is in the way because of this right here. The associative property says it doesn't matter what the order is when it comes to addition and subtraction. So 5 and -13, 13 there, 5 and -13, that gives us -8 plus 3b. And guess what? We took this from a multi-step problem. This is now a 2-step problem. Add 8, because remember, we're still on step 3 here. Combine like terms with regular numbers. 21 equals 3b. Then we divide by 3. And so b, 21 divided by 3, we see that b is going to equal 7. And so what I'm going to let you guys do is I'm going to let you guys try numbers 1 and 2 for me. See, make sure you give yourself plenty of room, space them out. Let's see what you got. Okay, so step 1, look for parentheses. We don't have any. Step 2, combine your variables. Well, we got them on the same side here. We can smash them together. -6 and -8 makes -14h. Drop everything else down. Oh, we got a +4 and a 60. We want to get that 4 out of the way so we can solve for h. So we subtract 4, 56. And then divide by -14 because it is being multiplied to h. So we divide it. H is -4. Now again, number 2. Number 2 is like number 3 up here. 5 and negative 13, even though they weren't next to each other, they're on the same side of the equal sign. And since they're like terms, we can mash them together. Same thing here. These are both on the right side of the equal sign, so we can smash them together. Negative 7 and 3 combine together to give us negative 4n. We can add 12 over because we want to get that out of the way, get it away from n, and combine it with its like term, negative 32. That gives us negative 20. And then you divide by negative 4, and n is 5. So we're going to end today, guys, with this last section, just practicing distributing. Let's look at what happens when we actually use step 1 here, whenever we do work with parentheses. So step 1, number 1. There's nothing we can do on the left side. It's just a number. On the right side, we have an 8 being multiplied to this right here. So r plus 2. These are not like terms, so we can't smash those together. They just kind of chill there. But what we can do is we can say, okay, if there's nothing in the parentheses that can simplify, we have an 8 on the outside, we can distribute into it. So we multiply 8 in there. 8 times r is 8r. 8 times 2 is 16. And you just took this from a multi-step problem, took one step, and now you are to a two-step equation. We can subtract 16, gives you 48, and then we can divide by 8. 48 divided by 8, r equals 6. And so, what I'm going to let you guys do, I'm going to let you guys try numbers, let's go number 2 and this number 2. So I'm going to let you guys try both number 2s here, and what I'll point out to you is on this number 2, you see how there's a negative there? We assume there is a negative 1 there. If you ever see a negative in front of a parentheses, we assume that's really a negative 1. So go ahead, guys. Give it a shot here on number 2. Both number 2s. All right, so number 2. Multiply 5 to 2x and 5 to negative 3. We distribute. That gives us 10x, and 5 times negative 3 is negative 15. Now we have a two-step problem. You can add 15 over. 15 and 15 gives you 30. And then 10 times x, our last step, we're either going to divide or multiply. If 10 is being multiplied to x, that means we divide. 30 divided by 10 is 3. And on this one, be careful. You're distributing a negative number. So negative 1 times x is negative 1x. And negative 1 times negative 4, a negative times a negative, actually turns that into a positive 4. So then, two-step problem, we subtract 4 over. Negative 22 and negative 4, we add those together to get negative 26. And now, this is where a lot of people make a mistake. We're not going to add 1. This is really a negative 1 being multiplied to x. So we divide by negative 1, and a negative divided by a negative, we know is going to be a positive, and x is going to equal anything divided by 1 is itself. So thank you guys very much. Your homework for tonight is going to be these bottom 3 problems. Problem 1, our word problem, which is a throwback to the word problems there that we worked on days 4 and 5. And then these 2 multiple choice problems. If you have any questions, you know how to contact me, and I'll be talking to you guys soon.